Good morning guys, Anjani Kumar here, dealing power system 2 for third year electrical students. Right? In a last session, we discussed about what is a corona, or what is the phenomena of corona. Right? So we discussed about the phenomena of corona. After that, how the corona forms. Right? And after that, various terms. So where corona plays a predominant role while designing your transmission system, right? So for a profitable transmission system, we need to consider the terms that what we discussed in a last session, right? So what are the terms that we need? There is a visual critical voltage is there, critical descriptive voltage is there, and after that visual critical voltage is there, some power loss is there. So what is a what is a critical descriptive voltage? The minimum voltage at which the corona forms. Right? What is a visual critical voltage means? The minimum voltage at which the corona glow will form. Right? Visual critical voltage vachinanta matrana the glow won't appear. Right? The minimum voltage at which the corona glow will form, that voltage we can call it as a visual critical voltage. Manaku kanapadtadi. Right? So what is the power loss? So when corona forming, there will be energy loss in the form of heat, light and some chemical reactions, right? So that power loss we can call it as a loss done by the corona, loss done by the corona itself, right? So we discussed about all the formulas and all these things. Those are very, very important formulas. So what is the formula for VC? Z0 delta M0 or log d by r. So where G0 is nothing but the gradient, so the potential gradient at which the dielectric breakdown of air, right? So while corona forming means this is a conductor, when high voltage there will be a potential gradient will appear, at which gradient your air dielectric air breakdown occurs, air gets ionized. So that voltage that gradient we can call it as a gradient, that voltage we can call it as a critical descriptive voltage. Hope it's clear, right? If it is a 10 kV, so this gradient is not sufficient to break down your air, right? So it will act as an insulator between the two conductors, right? If it is increases, the gradient increases, electrons force increases. Due to that force, electrons hit some air molecule and another electrons will form. So there will be electron path between the two conductors. It will make the conduction path between the two conductors, right? That is the process of corona forming. And what is the formula for VV? G0 is nothing but potential gradient at which the air breakdown, and del is nothing but factor, air density factor. M0 is nothing but irregular factor. R is nothing but the radius. D is nothing but distance, right? And after that, so what is a VV? Minimum voltage at which the corona glow will form. You will see a corona glow. So that is nothing but Z0 delta M0 or 1 plus 0.3 square root of delta by R kV per mm, right? So what is the power loss formula? Power loss is equal to 242.2 into F plus 25 by delta square of R by D V minus VC whole square into 10 power minus 5 kilowatts kilometer per phase. So these formulas are very, very important. So these are the important terms while designing your overhead transmission system when system is affected by the corona, right? So these are the things that we discussed up to now. Now we'll discuss about theoretical concept. What are the factors that we discuss about the factors that are affecting the system corona, and advantages, disadvantages, and after that what are the factors to improve the corona, methods to improve the corona, right? So these are the things that we discussed now. Hope you people understand what is the concept of corona at least, right? Now we'll discuss about factors. The first factor is atmospheric condition. Right? So atmospheric condition. If it is a rainy season, so the corona will be increases. If it is a rainy season, that means so there's sort of water particles will fill in air. So definitely there will be a less voltage required for a breakdown of air between the conductors, right? So that means water particle will be filled in an air. So that means what happened? Small voltage is required to break down of the air, because the water particle is a conducting particle, right? So you are inserting a conducting particle means there will be a less voltage required for a breakdown of air. Another season, definitely the corona formation will be very less when compared to the rainy season. Right? That is the first factor. The distance, right? The distance between the conductor. If you are increasing the distance between the conductor, the voltage required for air breakdown, it should be very, very high. So that means it will take time to form the corona. So that means distance increases, the corona formation will be very less. I hope it's clear. Distance increases now. Air breakdown అవడానికి ఎంత కావాలి? వోల్టేజ్ చాలా ఎక్కువ వోల్టేజ్ కావాలి. That means you are taking time to form the corona. So that means very less corona affected system. And the third one is conductor shape. If it is a solid conductor, the chances of corona is less. There will be a corona, definitely. There will be some hissing noise and some sort of glow will be present. So that means if it is a solid conductor, chances are very less. If it is irregular conductors, like some part it is a roughly based conductor, definitely in that part your corona glow brightness will be very high, and other parts the brightness will be very less. Right? So irregular surfaces, the corona will be high. That means ACSR conductor, you have some corona will be there. So but we require ACSR conductors. So not basic of corona, all effects are going to be minimized with the help of ACSR conductor that we are going to choose. Right? After that, line voltages. Right? So if you are increasing your line voltages, definitely the potential gradient will be increases. So definitely the gradient voltage at which the corona will form also definitely raises, right? Air breakdown will occur. The line voltages are increases, the corona formation also increases. Right? So, and after that, the fifth point is the air density factor. So if air density factor is increases, whatever the voltage that you require for corona formation also increases. That means it requires more voltages when air density factor increases. If more voltage is required means definitely you are reducing your corona. Right? More voltage required for a breakdown. That means it will take time to form the corona. So that means the air density factor also affects the corona. Right? After that, the diameter also. If you are increasing our diameter, so definitely the corona formation also reduces. That means you are increasing your diameter, or will be increases. Or increases means whatever the VC also increases. That means not that much voltage, heavy voltage required to form the corona. So that means what happened? It will take time to form the corona. So that means you are reducing your corona, right? So these are the reduction methods, but these are the things also affects the formation of corona, right? So what are the main factors that affect the corona? Means atmospheric condition, If it is a rainy season, definitely the corona effects are more, and other season there will be a less corona. And after the distance, if the distance placed in the conductor is a large, that means it requires more voltage, that means chances of corona is going to be less. And conductor shape, if it is a solid conductors, definitely the corona will be very less. If it is ACSR conductor, some sort of corona will be there, because irregular conductors is there na, some sort of layers, some are aluminum layers, some are steel layers. So that's why irregular surfaces, in that irregular surfaces, your corona brightness will be very high. If line voltages are increases, your corona formation also increases, because potential gradient is increasing, the forces of electrons are increases, number of electrons generated increases, corona glow will form. Right? Air density factor. If air density factor increases, Vc is directly proportional to air density na. So what happens? If air density factor increases, Vc increases. If critical descriptive voltage increases, means the voltage at which corona form is increasing. That means you are taking time to place a corona. So that means the corona formation is going to be reduces. Hope it's clear. That means diameter increases. So whatever the radius, diameter is increases, means definitely Vc increases. Definitely what happened? Corona formation is going to be reduces. And one more important factor, it's a frequency. If a frequency increases, the power loss increases na. What is the power loss? Which is directly proportional to frequency. If a frequency increases, the power loss increases, corona formation also increases. So these are the important factors that are affecting the corona. I hope it's clear. Atmospheric condition, distance and supply voltage, line voltage, conductor shape and air density factor, frequency and the diameter. Right? So these are the factors affecting the corona. Right? Now we discussed about the advantages and disadvantages of corona. Right? These are the factors. This is very, very important questions. Right? So what are various factors that affects the corona? And we'll discuss about advantages and disadvantages. Most probably there will be only disadvantages, but some advantages also present. The first advantages is, so whatever the surges, right? So surges means nothing but lightning strokes, right? Whenever the fault or lightning strokes that are high voltage that occur in a system, definitely whenever the surges placed on the transmission conductor, so there will be lots of energy generated, right? Lots of fault current is generated, but some of the energy loss in a corona. So definitely there will be a chances of protecting your conductor. I hope it's clear. If there is a conductor, when lots of surges present on the conductor, definitely what happens, the conductor will make damage. But when due to the form of corona, some amount of energy that are going to be losses in the form of corona. So definitely the effect of these surge voltages on the conductor, it should be very less, and it will be protect the system. Alright. So, and second one is it acts as a virtual conductor, right? So you don't have any conductor between these two between these two conductor, but you have one conduction path that you are creating. So it will act as a virtual conductor. I hope it's clear. These are the two advantages only, right? First advantage is it can be avoid the surges, that is transients that are going to be developed on the conductor. If a transients develop, means definitely there will be high voltages are developed. So then there will be high voltage developed, means the conductor will get some sort of damages that occur. And due to that corona formation, what happens, some amount of energy loss in the corona. So whatever the total stress on the conductor is reduces. So this is one of the advantages of corona. And second one, it will make a virtual conductor, right? And disadvantages. Right? So it is generating energy loss. So energy, there will be when a corona forming means definitely there will be a power loss or energy loss in the form of heat or light, some chemical reactions, right? So due to that energy loss, definitely the voltage regulation is reduces, and definitely efficiency also reduces. Alright. So whatever the when a corona forming, so whatever the surrounding communication lines or radio interference, right, there will be some disturbance will be created surrounding communication systems. It will making the surrounding communication systems will get damaged due to that corona. And the third one is right. So when corona forming, there will be some energy loss due to the light or heat in the form of some chemical reaction. So on that chemical reaction itself, there will be a ozone gas will be developed. Ozone gas developed under the chemical reactions, right? So this is one of the disadvantages, right? So these are the disadvantages when corona forming. So what is the advantages? The surge, when the surge happening in the system, some sort of surge is going to be lost in the form of corona. It will protect the system, and it will act as a virtual conductor. We don't have a conductor, but it will, the conduction path is there, right? So disadvantages means, so whatever the energy loss is there, so if the power loss means definitely the voltage regulation reduces, and after that the efficiency of the system also reduces. And after that when these type of corona forming means whatever the communication lines, right, harmonics are going to be developed, whatever the communication lines near the conductor will get disturbances, right? And after that when corona forming, some sort of energy losses is going to be developed in the form of light, heat and all these things, and some chemical reaction. In that process there will be some ozone gas also developed, so it will create a problem, right? These are the advantages and disadvantages of corona, right? Now we'll discuss about how to reduce the corona, methods to reduce the corona. You know the methods. Right? So definitely we should reduce the corona. Why? Because the successful operation of power transmission system must be depends upon how much the corona you are reducing, right? So definitely you should reduce your corona by with the help of some methods. So what are the methods? Right? We'll discuss, right? The first one is conductor spacing, right? So you are measuring distance between the conductor. So distance is increases, there will be a chances of dielectric breakdown of air is very less chances. I hope it's clear. Vc is directly proportional to the distance of the conductor, right? If a distance of the conductor increases, whatever the critical descriptive voltage, this voltage form the corona. If this voltage is increases, your corona formation also increases. That means corona formation will take some time. That means you are reducing your corona. I hope it's clear. You are placing a conductor large distances mean the voltage required means very large. That means corona formation, it will take some time, lot of time. That means you are reducing your corona effect. I hope it's clear. Next, second one, voltages, line voltages. If you are increasing your line voltages, definitely the corona value will be increases. So further, if you are reducing your corona, you have to reduce your voltages, right? Whatever the voltage that transmitting, it should be very less. And after that, third one is a conductor sizing, right? So lots of large size of the conductor. So definitely if the conductor diameter radius which is increases, your Vc also increases. That means high voltage that required for a breakdown of air and for forming the corona. So like large size of the conductor. And after one more thing is conductor shape. If you use a solid conductor, right? If you use a solid conductor, so what happened? The corona will be very less. But we go for ACSR conductor, so definitely it will be very more advantageous when compared to solid conductor. ACSR conductor, the corona effect is increasing, but the corona ACSR conductor will reduce other effects that what we are getting, like skin effect, proximity effect, Ferranti effect, are all going to be reduced by this ACSR conductor, right? So if you want to reduce a corona, you have to use a solid conductor will be preferred, right? But if you use a ACSR conductor, definitely the corona will be increases, but you should go for ACSR conductors, right? These are the methods for reducing the corona. So first one is a conductor spacing. If you are increasing the conductor spacing, you can reduce your conductor. Second one is if a voltage increases, your corona is going to be increased. So lane voltage must be reduced. And if the conductor size increasing, definitely the voltage required for forming the corona also increases. That means you are reducing your corona. After that, if you use a solid conductors, right? If you use a solid conductors, definitely you will reduce the corona. But we prefer ACSR conductors only. Alright. So these are the methods for reducing the corona. I hope it's clear overall the concept of corona. So what we discussed till now, I just want to clear brief idea. We discussed about what is corona. Corona states that phenomena, hissing noise, violet glow, and ozone gas around in a overhead transmission system, that we can call it as a corona. After that, mechanism of corona. Right, how the corona form means, whenever high voltage transmission system, there will be a air breakdown occurs. Right, when a breakdown occurs, definitely there will be a conducting path between the two conductors. It will form a hissing noise and violet glow on the conductor. So this phenomena we can call it as a corona. How it will created means, when high voltage is transferring, there will be a potential gradient will be increases along the surface of the conductor. More voltages will be present. These voltages will increases the force of electrons, free electrons between the two conductors. These free electrons hits the air molecules. Definitely another electrons will be generated on another electrons will hit another air molecule. Another electrons will be generated. Due to it, there will be a electron formation between the two conductors. There will be a conducting path will be developed. There will be an arc will be struck. This will form a violet glow. Some sort of hissing noise will be present around the conductor. This is a mechanism how the corona forms. Next, what are the important terms? So, successful operation of a overhead transmission system must be depends on how affecting the corona itself. Right? There will be consider some important terms. The terms are critical descriptive voltage, visual critical voltage, and some power loss. So, what is the visual critical descriptive voltage? The minimum voltage at which the corona forms. Alright. The minimum voltage at which the corona forms, we can call it as a critical descriptive voltage. What is the visual critical voltage means? The minimum voltage phase to neutral voltage at which the corona glow will occur. And what is the power loss? So definitely when a corona forming, there will be energy loss in the form of light, heat, and some other chemical reactions. So that loss we can call it as a power loss in the overhead transmission line due to the corona. So power loss is directly proportional to the frequency. This is very, very important consideration. And we derive the formulas and all these things. So you just have to note it down. And after that we discussed about the factors that affecting the corona. Right? So what are the various factors that affecting the corona? So factors are atmospheric condition. If it is a rainy season, definitely the corona will be very high. That means water particle in air, definitely voltage required for a breakdown of air is very less. So there will be a chances of corona is very fast. Next, if the frequency increases, definitely the corona also increases. If the conductor spacing increases, the corona formation also reduces. These are the effects. And after that, air density factor increases, the voltage required is increases. That means the corona you are going to be reducing. The voltage level and corona size, conductor size. If it is a solid conductor, the corona will be very less. If it is a rough irregular conductors, the corona at different places is a more brightness. If it is a irregular spots, means more brightness at regular spots. Right. So these are the factors that are affecting the corona. After that, we discussed about advantages and disadvantages of corona. So what are the advantages? Means power swings, like transients. If a transients happen in the system, definitely there will be a large voltage appears on the conductor. But some of the voltage losses in the form of corona, there will be a protection of the conductor. And after that, it will act as a virtual conductor also. And what are the disadvantages? Means if energy loss means the voltage regulation is reduces, efficiency also reduces. That means if forming the corona means it will affect nearby transmissions, nearby communication systems also affected. Right. So ozone gas is going to be produced under the chemical reaction at this point. So these are the advantages and disadvantages of corona. And last we discussed about the methods to improve the corona. So what are the methods to improve the corona? By making the distance between the two conductors, you are going to be reduces the corona. That means methods to reducing the corona. That means your distance between the conductor increases. Definitely the corona formation will be reduces. The first one is. And the second one is, if you use the solid conductors, definitely the current corona value will be very less. Right? But we require ACSR conductors for more useful. And the third one is what we discussed. And we discussed about the conductor size. If the more conductor size, definitely the voltage required for a breakdown is increases. That means you are reducing your corona effect. Alright. If you require for a low voltages, the corona formation also very less. So these are the concept of corona that what we discussed till now. So this is about all the factors that are affected in our overhead transmission system. Those are skin effect, proximity effect, Ferranti effect, and corona. I hope we discussed in detail each and every effect with neat sketches and all these things. So definitely you people should follow these videos at least once for your for a technical improvement. So while if you entered into a diploma candidates, or else if the person wants to go for a technical jobs, definitely these type of concepts will be helpful for you, right? What is a corona, what is a skin effect, what is a proximity effect, what is a Ferranti effect, how it will happen, right? How the hissing noise is developed. Definitely you will say that whether the corona happening means there will be a hissing noise and violet glow will be present. How those type of formations are created, right? You just need to explain it. It will be very good for you. As an electrical engineer, you should know how the power system working, how the transmission system working, how the factors in a transmission system, that all the things that we need to know. Right? I hope you people will understand all the factors that affects the transmission system. If you have any doubt, feel free to ask me. I'm here for you guys. Definitely I'll explain all the doubts that what you have regarding the power system 2 subject. Right? I hope each and every person follow my videos at least once. That's enough for me. It's my humble request. With this, definitely you will improve your subject, right? I will assure that if you follow my videos, definitely you will gain some minimum knowledge regarding power system, how the transmission system how the transmission lines are erected, how the insulators are working, how the string efficiency, that what we discussed in detail, right? Hope all the person should follow and watch my videos at least once for your improvement of subject. Right, thank you for now. Thank you very much.